Hello and welcome to a webinar hosted by World Pipelines with PenSpen. I'm Elizabeth Corner, the Senior Editor of World Pipelines, and today's session is entitled The Tide is Turning, the Role of Digitalisation in the Pipeline Integrity Industry. The presentation will be led by Nigel Curson, who is Executive Vice President of Technical Excellence at PenSpen. And Nigel's going to share some insight into digital transformation in the pipeline integrity industry and PenSpen's approach and the lessons learned. At the end of the presentation, Nigel, along with Aidan Charlton, Technical Manager of Digital Services at PenSpen, will join me for a live Q&A session. Aidan currently works for PenSpen Thea in Newcastle as a Senior Engineer and Technical Manager, and he leads a team of engineers in the development of digital integrity models and techniques. So if you'd like to submit a question for the Q&A, you can do so at any point during today's webinar. For those of you who are joining us on mobile, you can access the question box by simply tapping the icon at the bottom of your screen. If you're using a desktop or a laptop, just click the orange arrow on the right of your screen to open up the user interface and to reveal the question box. A little heads up, we'll be running a poll. Everyone who registered will receive a full recording of the webinar after today's session. So I will hand you over and let's begin today's presentation.
Thank you very much, Elizabeth. Just to recap on the title. The tide is turning, the role of digitization in the pipeline industry. That's what this webinar is about. That's what I'm going to talk about. And what I'd like to cover is, first of all, what's pipeline integrity? I'm sure most of the audience will know, but just to be clear, that's certainly what I'd like to talk about what our perspective is. Background, there's something which we're calling the industry quadrilemma. Typical scenarios that operators are facing today. Some of the opportunities that technology are bringing, some of the new data sources that are now, and then the fourth industrial revolution, the opportunities that's bringing, and how we've applied that to pipeline integrity. Some examples of solutions and research that we've been doing, and then as our product Thea, a little bit about what we've achieved with that, where we are, some of the challenges and roadblocks that we're facing and exploring. So first of all, what is asset integrity management? From an operator's perspective, an operator is always going to take an enterprise risk management perspective, and that would include a lot of different elements, existential risks, and very, very unlikely events such as global pandemics and negative oil prices. Part of that is the risk that the asset presents to the environment, people, and reputation in the business, and management of that risk produced by the pressure-containing asset, in this case, is the pipeline integrity management system, and there are a few of them. You can see on the left here we've got asset integrity management systems, AIMS, and then the one we're mainly talking about today is PIMS, or pipeline integrity management system. There's also a SIMS structures and a WIMS for wells. So we're very fortunate that this has been a concept that's been around for a few years. PenSpen like to think in terms of 17 elements, and you can see that in terms of pipeline integrity management systems, it's a very broad concept dealing with objectives, procurement, design, qualifications, competencies, and of course, risk assessment is the core of it. And there are a lot of codes that deal with this. ISO 55000 is an even broader concept, dealing with risk and decision making, which is an important part of that. So what we're trying to achieve with our pipeline integrity management system is the management of risk, and this is throughout the life of the pipeline. So you can think in terms of the vertical axis here is risk, horizontal axis is time, and we have what we can consider an intolerable level of risk. So when we start out designing our pipeline, of course, there is no risk or very limited risk because it hasn't been built yet. So we use techniques such as FMEA, HAZOPs and hazards to manage the risk of the future pipeline when it's operating. So we continue with this process, and eventually we'd reach a point where the risk as layer is reasonably practical. Again, we haven't built it yet, but we're predicting it, and that's a common way of determining whether a risk is reasonable or not. Then we go through our construction phase. Nothing really changes. Then we move into operation, and pretty much as soon as we start to operate, or we start to get an increasing risk, or after a certain amount of period of time, because we get a degradation of the pipeline, degradation of coatings, accumulation of damage, we get fatigue damage, and we may intervene, and that will actually reduce our risk. That could be a repair or an upgrade or a down rating. That reduces our risk, and then we'll continue to operate our pipeline, and eventually we reach a point where the risk is intolerable. There's nothing more we can do. The asset may have been past its useful life, and then we depressurize it, and then the risk reduces considerably, but it doesn't actually reduce to zero, because it's very unlikely that a pipeline will be completely abandoned. Abandoned meaning that the operator no longer has any responsibility. If it's a subsea pipeline, there's a residual responsibility for maintaining it, and it does pose a threat to fishing activities. If it's an onshore pipeline, then of course it's large diameter, it can affect water courses. And also there's the UK maximised economic recovery strategy, which means that even if you have actually decommissioned the pipeline, you may actually have to maintain it because it has potential useful life for exploiting other assets. So really, when we talk about pipeline integrity management systems, this is the risk that we are the core of it is really managing this risk. So in terms of industry background, we are talking about a concept which we're calling the industry quadrilemma, and this is 4 things conspiring against pipeline integrity management. And the first one is aging assets. Many of the assets that certainly we're involved in have been operating for a very long time. And in the US, we're very close to a 100-year-old pipeline. Certainly many pipelines have been operating are 40, 50, and 60 years old. And many of these are reaching the end of their life in terms of you may have heard the term the bathtub curve, where the failure rate increases. And this works with the number 2, which is scarcity of resources, because the skill sets are changing, because the skills for designing and operating a new pipeline are different from those for managing a pipeline that's starting to have issues. And also, generally in oil and gas, there is a scarcity of resources because the industry is cyclical. It's not, I think we have to admit, it's not the most fashionable thing for grads to move into. A lot of the average age in the industry is quite high, so a lot of people are actually retiring. And there are, initiatives in various nations to nationalize. So there is a scarcity of resources. Also, more and more legislation. Governments are realizing, that these are critical assets. They're potential liabilities. And so there is more legislation. I mentioned one, which is the maximising economic recovery UK strategy, and also the financial outlook. The rapid fluctuations in oil price lead to a lack of confidence in investment, and also less money from the asset generally, but with low commodity prices, so less money around to spend. So all of these kind of work against us. So Elizabeth mentioned we were planning on doing a poll, so so I'd like to launch that. So this is the question we'd like to ask. So I understand you have an interface on your screen and you can select one. So first of all, access to competent resources. So what's the biggest pain point? Access to competent resources, the overall cost of pipeline integrity management to you, including repairs, inspection teams, dealing with data management, dealing with failures, and getting value from your data. So please provide your votes. The tension mounts. So very interesting. So data management, 31% top. We've got dealing with failures and aging assets, 21%. Then we've got getting value from data, 19. Overall cost, 18, and right at the bottom, accessing competent resources. So that's interesting. Thank you very much. So Tom, if you go back to the slide, please. Thank you. So in terms of background, this is a typical pipeline integrity management scenario. Most operators, and even the most sophisticated, tend to have a proliferation of spreadsheets, multiple enterprise resource systems, multiple disparate data sources. You'll often find data has been lost, there's been changes in ownership, so data is not available or not in easily consumable format, still in paper format. Single user applications, and it's very, very hard to get insights and make decisions. Sometimes just doing the minimum is hard work. So, so the drawing on the right, is a typical situation. So this is a recent study has been done on the UK continental shelf, and this is Deloitte's came up with a digital to maturity index, and you can see oil and gas in terms of their ranking of digital maturity is the lowest compared with all these criteria. Technology, telecom, and interesting, travel, hospitality, and leisure, some of the highest. It sort of indicates what our priorities are. Part of the same piece of work, operators were asked various questions about digital transformation drivers, and the top came out as increasing availability and access to data, increasing levels of insight from data, reducing cost again was a key one, and then of course reducing risk was a key one. Interesting, developing user-centric ways of working was not a key one. Interesting, so that would indicate that operators or oil and gas companies, are willing to work in different ways to accommodate different methods. So I would say that really from a digital transformation point of view, the tide has been out, but I think it is starting to come back in again. So again, background in evolving technology. The graph on the left is really why artificial intelligence has been on the rise. I mean, artificial intelligence is talked about all the time. It's in the press. It's making decisions for us. It's part of our lives. And really, it's not surprising, really, because Moore's law in computing, between 2000 and 2017, we've had something like a 10,000-fold increase in processing power. And the cost of storage has gone from 12.5 gigabytes to dollars a gigabyte in 2000 to about 0.4 cents in 2017. So massive reduction in cost. So an exponential growth in data as well, because it's easier to process it, much cheaper to store it. And on the right is a process in computing. If you think about a single thread CPU, Moore's law has been the norm for several years, which is the doubling the transistors on a circuit board every 2 years. So we've had a massive increase in conventional CPUs, but now GPU computing is taking over, and graphical processing units have something like can have as much as 5,000 individual processors or cores. But the NVIDIA Titan GPU has about 4,120 cores. Same is actually available as cloud solutions, not so many cores, but slightly different technology. So this is all available in the cloud. So again, this is meaning that high performance computing is becoming much more achievable. The other background is just generally about cloud computing. We have a whole rake of web services and ways of interacting with other data. We have protocols that have been developed that allow us to interact with different systems. So PCs can talk to Macs, can talk to Unix systems, can talk to Linux systems. We have SOAP, REST, and XML, RCP. We have APIs, and which can access a wealth of different sorts of information and resources. We have a wealth of open source. Some of the best research is actually being done on open source codes. Examples are MongoDB, Postgres, Kubernetes, Jupyter Notebooks, Angular, and there's many other ones. Very important research is being done in these areas. And also software as a service. No hardware and pay as you go. So really you can snap your fingers and get enterprise class services or computing, within minutes, paying with your credit card. This is enormously empowering, and it's helping with collaboration, problem solving. We can provide maps and payments, all sorts of things really very, very easily. Gartner, you've probably heard of. Gartner do a lot of research on IT and digital transformation. And in their view, they're saying half of global enterprises will using the cloud will have adopted an all cloud strategy by 2021. So this is very empowering for businesses generally, and will be empowering for the pipeline integrity business. So also expectations are changing. Everything's just a few clicks away. We've all experienced Amazon. You can search for something, you click, and it arrives the next day. Or in 2 months' time, if you're like me and you didn't realize it was coming from China. So this makes our life very, very easy. And also the background in live data sources. We've got a rake of, I think companies are recognizing the opportunities here, and there's a rake of autonomous sensors that can be used. So we can access live data or quasi-live data, and we can measure things in real time, such as strain, pipeline curvature, vibration, position, pressure, flow rate. We can monitor our CP system, and we can get information from other sources such as weather, forecasting, currents, wave, and wind, which we can get again live. And also new types of data sources as well. I mean, I've given a couple of examples here. There's been a lot of research on synthetic aperture radar, and particularly using persistent scattering points, or SPSP, which can be used to actually very accurately measure ground displacement on a movement of objects. And this can be used, this is actually sub centimeter, so millimeters of movement, which can be used, can be very, very useful for looking at pipelines which are in high rainfall or high slopes, to measure and predict degradation or strain of pipelines. And similar improvements in subsea imagery as well. The traditional way to do a subsea survey would be to actually video the pipeline and then watch the video in real time. But there's now been developments of fast digital imaging inspection, or FDII. So the rate here is, instead of something like 1 kilometer an hour, it can go up to 5 kilometers an hour, much quicker. And it takes high resolution images, and also it can use laser scanning to actually produce a 3D model, and this can all be combined into a 3D SLPK model. So you can have a three-dimensional representation rendered by an image, and it's possible to combine this with automatic anomaly detection as well. So the future could be autonomous ROVs, unmanned, that go out, do a fast digital imagery inspection, and actually come back with anomalies already recognized. So another area which is existing really is 3D laser scanning. The process of collecting external and measuring external defects has been typically quite tedious, but with digital scanning devices and integrated software, this can be done very, very quickly, something 3 times the speed and 4 times the resolution, so better results and much faster results. So really, if you put all this together, We've heard that you may have heard the term Industry 4.0. This is something which is evident in many industrial applications and becoming more relevant for pipelines. Really, the progression really is from Industry 1.0, the Industrial Revolution, where we had steam, and then Industry 2.0 with electrical power, Industry 3.0 with automation, and now we're in the Industry 4.0 hyperconnectivity. So this would include interconnections, IIoT or Industrial Internet of Things, artificial intelligence, machine learning, big data, and live data. So this is bringing tremendous opportunities for the pipeline industry. So what can it do for us, really? I mean, of course, from an operator's point of view, anything to do with intervention is very, very expensive, particularly so for subsea, and particularly so for deep water subsea. Very, very expensive indeed. Something you want to minimise. So really, anything you can do to have a better stab at predicting remaining life or optimizing it. So monitoring and use of sensors and analytics can allow you to have digital twins, so you can simulate your asset in a computer environment and actually use it to predict its performance, and use that to make actually decisions about the way you operate it, the way you repair it, and the way you use it in the future. So that would allow you to have things like live fitness of purpose, live validation of inspection periods, live management dashboards, and live life cycle costing. So you can see the impact of your decisions to manage your asset much more effectively, real time. And also, lastly, automated anomaly detection as well, with much quicker results. So you can run an inspection vehicle, whether it's a big or external, and actually get results very, very quickly based on automated detection. So it gives you better decisions. And these are some of the work that we've been doing and incorporated into Thea. And one very important thing is aligning data. Typically with pipeline integrity, you're taking data measurements over a period of several years over the life of the pipeline, and using these to actually make decisions to come up with a prognosis, whether this is internal data from an intelligent pig, or external data, or strain gauge, or from strain gauges, or from running a pig and looking at strain. So operators, or in fact we have been challenged with this. It's the most time-consuming aspect of doing analysis. So we've experimented with a lot of different analysis techniques and managed to come up with ways of doing it very, very, very quickly. And this can be based on a number of different characteristics of the pipeline, including joint length, or even strain, and a few other things as well. So we can, within seconds, match different data sources, and this gives us a much better way of predicting future failures and degradation. The other thing is having a better understanding of degradation along the length of the line as well. Often with the data you have to make assumptions about corrosion growth rates, and often make conservation assumptions. With better analysis and better data and better data alignment, you can actually make judgments of corrosion growth rates or degradation along the length of the pipeline. And you can use data science to actually determine whether the data rate you've come up with is credible, whether data points are credible in deriving that. And you can use this for strategies. You can actually differ the strategy depending on the part of the pipeline you're dealing with, or change your operating scenario to give a better result. So really it gives you, in terms of benefits, better understanding of the mechanisms, better failure predictions, and better results and actions. And the other thing is moving to probabilistic assessments as well. Often when we're doing this type of analysis, you're really forced into a position where you have to do it in a deterministic way. Whereas that actually doing it from a probabilistic way would be much more logical from a scientific point of view, because you can take account of variations in measurements, take account of variations in material properties, You can take account of the variations in the load that the pipeline is experiencing. But to do this in any practical time frame, using there are a number of analytical techniques, but a robust way of doing this is using a Monte Carlo simulation. But it takes an extremely large number of iterations. It's an iterative process, but using GPUs and very fast computers, it's very practical, very practical to do this now. And we've been experimenting in doing this. So really, it's the benefit there really is giving probabilistic remaining life. So you can say the probability of remaining life is this, rather than a completely deterministic result. So really, better decisions, more informed decisions. And also automation. I mean, I don't know if you've ever sat through a subsea video, but it's quite a tedious endeavor actually identifying anomalies and coming up with remediation plans. But we know from work that's already been done, and we have a technology partner, QIO, that's done some work with water pipelines. But it's possible to use a convolutional neural network to actually train it to identify features to automate this process. There's been some work done by various parties to prove this is perfectly feasible. So again, faster identification and better. In fact, where this type of technology has been used in the past, particularly in medical science, it's been proven to actually better than the human eye at actually detecting things. So potentially better and faster. Also dealing with complex features. Often when you're analyzing the integrity of a pipeline, you have denser interaction with defects or defects that are, or corrosion anomalies or interaction with each other. So you end up using boxing and simplifications. Whereas with much faster computers, it's quite possible to actually have much more sophisticated analysis and actually remove those conservative assumptions that you have to make. So, and also doing things very quickly as well. Within THEA, we can drag across an inspection report or an inspection data. It can ingest that. We can set a few parameters and actually produce the automated report in 30 seconds. So really, and also not only that, but from the data, we can produce insights. So one possible question would be, why do we need a report? Well, with the reports, you always need a report because there's always some kind of insight, needs to be some narrative that needs to be explained. So I think just saying it's okay is not enough. You need a narrative associated with it. So, and I think putting all this together, one beauty of this is if you can have dynamic lifecycle costing, you can do what ifs. What if I derate? What if I stop a corrosion inhibitor? What if I add more corrosion inhibitor? What if I don't inspect next year? What are the implications? So I think with this kind of environment, I think it allows you to do very quick what ifs, and use you to manage your asset more effectively. So it gives you a better understanding of the consequences of your decisions. So in terms of Penspen's vision, we have this vision of integrity management in the cloud. And really, it's very broad, and it's synthesizing pretty much all the things that we currently do for our clients. So we want it to be native cloud. So no virtual machines or remote desktops. So just a browser. So it could be used on simplistic machines or tablets. We want it to be integrated with ERP solutions, including Maximo, Esri, SAP, OSI Soft for collecting data. Data ingestion and alignment. We want it to be able to recognize any kind of format you can throw at it. We wanted to include document management because we know that's an important thing. We want to be able to access live data feeds, to use that to get insights. Flexible users and holistic KPIs. Role-based portals, so that individuals with clearly defined responsibilities, can log on and only deal with the information that's related to their particular role. Document libraries, benchmarking, operators compare themselves with other operators, and enhance security and control of data, of course. So that was our vision for our product Thea. And we have achieved most of it, I would say, and with the help of a technology partner, QIO. QIO are an industrial analytics company founded about 3 or 4 years ago. They work with some big names, including Rolls-Royce, looking after their aero engines, and they built this stack, which we've built our Thea product onto, and very, very quickly. It's got 3 different layers. There's a data layer, a modeling layer, and an application layer. And on the data layer, this is where you suck in, for use of a better word, data into the cloud environment, and that can be from real-time devices or real-time sources, and it can be from edge cloud solutions. Edge is where you actually put a processor close to the data source and process it close to the data, and then transmit at a lower data rate. And also ingesting file-based systems such as inspection data, or or interfacing with APIs from other systems like the ERP systems, SAP Maximo, or OSIsoft. So that ingests and puts into the data landing zone, and then there's a visualization service allows our engineers or QIO engineers to look at data, and then we use that, and we've developed a number of models already for various functions. We can develop using artificial intelligence or other methods within this environment. We can develop models which are then put into applications for the users to use. So sitting at the top there, you can see users and user and admin would actually access the applications to get the insights from the system. So this is the platform that Thea is based on, and it's built from a whole variety of open source codes. And it's maintained. I can't remember what the current version is, but it's been around for a few years, and it's continuously being improved. So in terms of what we have so far, one thing that a lot of our clients are very, very keen on is customizable dashboards. So we built that into Thea, and that has traffic lights or dials. And we can collect data from any external data source, whether it's an ERP system or it's live data from OSIsoft, and also some of the data is actually generated from within Thea itself. And we actually have these actually are screen dumps from Thea. We can actually have a whole system perspective or an individual pipeline perspective. And we can also look at from a temporal time-based perspective as well. So in other words, we can see the change in our data. So this allows operators to produce fully customized KPIs to monitor their assets. The other thing we've invested a lot of time into is really getting from the data upload to the reporting very quickly. As you can imagine, there's a very wide variety of different data sources or formats, and also you'll find that in some countries they use the comma instead of the point, and then the point instead of the comma. So that does create issues. So we've come up with some general ingestion algorithms, and we can go through from the ingestion by dragging a file across and go right through to producing a report very, very, very quickly. And the reports, has the whole methodology. Insights are all automatically generated with real data. All the graphs are real graphs from the data. And also we've written the reporting tool in such a way that you can actually do it in different languages. So this example here is in Spanish, but there's no, as long as it's left justified, we can pretty much cope with it. Maybe right justified in time. So The other area, of course, is very, very important. Is it's generally migrating data, because we recognise that for Theia to be useful, operators have a lot of different data sources. So we put a lot of time thinking about that, thinking about how we can connect to live data sources or migrate data, into Theia. The other aspect, of course, getting back to the quadrilemma, is training and development. So several years ago, we embarked upon developing a very large number of e-learning modules. These have been developed for MSc courses and a number of external courses, and these are all been put into an e-learning system, and there are about 10,500 slides in this, and they deal with a very, very broad range of different aspects of integrity, including defect assessment, geohazards, materials, offshore and onshore pipeline engineering, and risk management. So within Theia, there's a wealth of this information, and it's actually not set up as in a learning management system, but it's actually in a very, very structured format. So you can actually dip into it to get more information about the thing you're endeavoring to find out about or do. And of course, data visualization. We never really are going to attempt to compete with a product like Esri's ArcGIS, but it's nevertheless it's very important, I think, to overlay some of our insights and conclusions onto maps. So we have integrated Theia with maps, and you can see here there's examples of where we're showing very, very large strains in pipelines. From an aerial survey, so we can integrate satellite imagery or maps very easily. So in terms of the challenge, we're about 18 months, 2 years into this process. So in terms of challenges, getting enough data is one thing. Whatever you're trying to do. Particularly if it's artificial intelligence, you needed a good curated set of information to train the system to enable you to do the automatic detection. We find that many of our clients have invested in legacy systems. Again, this is potentially a challenge for us. And of course, cost of centralization. In an ideal world, all pipelines were bristling with sensors, but it is expensive, particularly for subsea pipelines. I mean, there are battery lives depending on the kind of communication protocols you're using or communication techniques. There are battery lives now up to 20 years. Some are less, some are only 2 years. So lack of interoperability between IT systems, lack of robust data formats. There is quite a bit of work being done on that right now. Lack of free flow between stakeholders, complex contractual relationships, and some clients are, of course, have the security concerns of putting things into the cloud as well. And the other aspect, of course, is skill requirements. With our product, which is software as a service, we're actually expecting our clients to actually operate this themselves. That's the idea. It's easy to use and quick, but not all of them are really worked in that mode. So we've kind of got around that by offering a number of services. One of them is actually where we do the work ourselves, provide our results in Theia, or the client does it and we provide support, or the client can just use it themselves effectively, just pay a subscription service. The other aspect in terms of skill requirements is that the routine tasks we're finding are now very quick and easy to do. This really frees up time for our engineers to actually add value, and it's kind of driving a new skill requirement. Because the more routine things are done easily, you can data science and such. Getting insights is becoming a more important thing. So pipeline and subsea engineers of the future, with digital skills is very, very important. So, but I think this is very positive. It's a career opportunity. It's a way of attracting new blood into the industry, which may have been otherwise difficult. So, but there are a lot of positives. you know, we find that one operator alone typically doesn't have enough data, unless they're a very large operator, to do machine learning. However, you know, there are a number of initiatives. Not all of them I've actually mentioned here, because some of them are in their formative stages. I mean, 4Subsea FlexShare is one example, which is collecting experience related to flexible pipelines. And there are a number of initiatives related to data exchange as well. Pipeline ML, which is a standard which is under the Open Geospatial Consortium, which was completed in June 2019. And there's another initiative, PDEF, which is focused on subsea information, which is GIP, which PenSpen are actually part of. So there are a lot of good things going on, which you know, would help with digital transformation. And also security. You know, I think there's a lot going on with security. There's a standard ISO 27000 27000. Our THEA product is ISO 27000 certified, but also there's a general move to the cloud environment. And in fact, you know, there is an overriding sense that a cloud environment might actually be more secure than, you know, the conventional computing environment. I mean, one benchmark here is the fact that that the Joint Enterprise Defense Infrastructure JEDI initiative, which was put out by the Pentagon, which is basically a $10 billion contract to you know, to build a cloud environment for their information. So arguably, if it's good enough for the Pentagon, it's good enough for oil and gas. So just a few last slides, and this last one I'd like to show you a video. So I'd like you to meet our team member Raheel.
A day in the life of Raheel, a pipeline engineer. With a fresh pot of Arabica coffee on the go, Raheel's day is off to a smooth start. But here comes the latest inline inspection data. 10 gigabytes? Looks like you're going to need more of that coffee, Raheel. There's so much data, all with different formatting and so much work to do. But Raheel has an idea. THEA is our new, secure integrity management solution in the cloud. THEA makes light work of all the data, utilizing advanced data and engineering analytics to provide useful insights into Raheel's pipelines. Now that Raheel is spending less time managing and formatting data, he can focus on the safe and efficient running of his pipelines. Go on, Raheel, have another coffee. You've earned it.
So in summary, you know, digital transformation has a lot to offer. You know, in terms of industry 4 concepts, a lot of the honesty industry. Certainly, it's going to lead to better insights and better decisions. THEA is certainly part of this. There are some roadblocks; they can be overcome. The industry will benefit from closer cooperation as it is. You know, and I think the link between engineering and data science is becoming increasingly more important. I think that's creating great opportunities. So, you know, try explaining asset integrity to a computer programmer. That can be quite tough. No disrespect to computer programmers. So really, you know, THEA is there. It's part of an industrial analytics platform. We'd love to hear from operators. We'd love to put more data into it. We'd love to collect it to more and more live sensors. So thank you very much.
Thanks, Nigel. That was excellent. Great presentation. We are now going to move on to our Q&A. So Nigel is staying on the line, and we should be joined by Aidan Charlton. Can you hear me, Aidan? Hi. And can you hear me?
Can we hear Aidan?
Just unmute yourself, Aidan.
Okay, we'll try a different microphone.
Great. Okay, so we've got a number of questions that have come in already, but there is still time to send more. So if you do have a question, please ask it by typing it in the question box. We'll try and get through as many as we can today. any that we don't get around to, we will pass them on to the PenSpen team and they can follow up later. So let's get on with our first question. The first question is, how secure is this environment?
Nigel, would you like to answer, or me?
Oh, no, I think you should answer that one.
Okay, so one of the most important things really with security is it's got to be traceable, and in this case, we're ISO 27000 series accredited. And the other part really is, as with everything, pick the right partners. You know, we believe we've picked the correct industrial partner. The advisory board for QIOs is quite high powered. You know, we've heard from Nigel that the likes of the US Department of Defense, UK MOD, they're all transitioning to non-physical infrastructure to the cloud. And by picking the correct technological partner, they have the right backing behind them. And in this case, QIO, on their advisory boards, they have an ex-deputy director of the NSA, who presumably looks after some of their security requirements. And also we have the founder of the internet, Tim Berners-Lee, as advisory board to QIO as well.
Okay, and a follow-up question to that, can Thea be implemented in a private cloud?
Shall I answer that? It certainly can. Yeah, it'll sit on AWS, Google, any cloud infrastructure effectively. So it can be set up in a client's own cloud environment, or we can even provide cloud in a box. So yes, okay. Absolutely. Yeah, as someone that's really concerned about security, that's certainly a possibility.
I've got a question here that follows on from that, from Nelson, and he says, good afternoon, how would I use cloud computing when there isn't an internet connection? Onshore pipelines often cross, large countries. There might be internet blank spots.
Okay, that's a good question. Potentially, you might have to get into an area with better reception. We tend to find today, the increase in coverage. It's very rare now to find an area without coverage, perhaps in the wilds of Scotland or somewhere like that. And this is something that will have to be considered by every company when they I guess, investigate their IT requirements and lone working requirements even. If you can't contact an employee, then potentially that's something that needs looked at in its own right as well. I was going
to say that's quite a common problem actually. I mean, it's quite feasible to collect data offline and then synchronize it when you later become online. If you think about the kind of field work you need to do with Thea, a lot of the Thea concepts are office based anyway. But there are situations where you want to collect data, perfectly reasonable that you could collect it offline and then synchronize it online later. So I don't think that's a major. And also with with Starlink satellites, I think internet coverage is going to become pretty much everywhere in the world, within the next 10 years, even 2 or 3 years. So.
Okay, Shiv asks, can this be integrated with different existing pipeline data models such as ESRI, APDM, pods, and other existing data sources?
Yeah, we can map across from one to the other very easily. So data can flow either way effectively. So.
Okay, and GV Gokula, he is asking, how is it different from pods?
Good one for you, Aidan, I think. Good question.
So pods is a data format as much as anything. It's not an assessment methodology or a computer system or software system or anything like that. It's strictly a data format. And actually, a lot of the work we have done with pods has shown that the way data is being transferred in between companies, and this is quite commonly under pods formatting, the way this has been implemented actually in real life, it's not being done to a common enough format, which enables automatic recognition without error. And whether this is a problem with how people are interpreting the pods standard or areas of pods which needs firmed up a little bit in further revisions. Either way, data transfer is one of the major roadblocks in pods particular. Yeah, the way it's being applied by industry at the minute, it's not quite sufficient. So we spend a lot of time on data cleaning to enable plot recognition.
Thank you. Let's move on to the next one. So Matthew McLennan is asking, what can sensor manufacturers do to make it easy to connect to the Thea platform?
Oh, that's very easy. Just have an API we can connect to.
Easy one.
Yeah, or collaborate with a company that can provide an API that we can connect to. So if it's got an API, we can connect to it effectively. So, but we're looking for, we're looking to have partnerships with if the sensor companies out there, we're looking to partnership to actually, apply Thea to the data that they collect.
Great. Something from Al, who asks, will PHMSA eventually mandate full digitization for integrity management? E.g., is there anything in the mega rule?
For Nigel, I guess.
I very much doubt it. I mean, I think the US legislation is prescriptive, so it's very likely that data formats will evolve for providing information that becomes a legislative requirement. But to mandate full digitalization, I'd be very surprised, because there's such a wide range of operators. I mean, there's I don't know how many thousands of operators there are, lots and lots in the US, for example, small, so I think that will be too burdensome, really. But providing data in digital format, I wouldn't be surprised if that became mandatory. But complete digitization, I'd be very surprised. I would think not.
Okay, thank you. I've got Calvin here who's asking, can you speak on how you could incorporate geohazards likelihood as opposed to, say, corrosion rate and creating an overall higher probability of failure?
Yeah. No, we've done a lot of work in areas which are subject to some major geohazards, Andean regions, for example, where they have high slopes, high rainfall, have very high valuable pipelines, and we came up with a number of different methodologies where you can recognize features and actually determine the risk of failure by landslide. By looking at the features, and obviously look at the sensitivity of the pipe to movement, its current position, and so you can we have built risk assessment tools, and we'll build that into Thea for it, and we already have built-in strain assessment into Thea. So that's of course one way of quantifying a geotechnical risk, looking at how things are actually moving. So yes, absolutely. Yeah, I mean, we will include and have included pretty much in most cases in every kind of threat in some way or other.
I suppose it's worth expanding a little bit. One of the common problems that we see throughout is aligning data together in an automated way, so it's fairly quick. It could take a human being a few days, a week, whatever, to align IMU data sets, if that's all you've got, the IMU data. We're down to about 3 seconds at the minute for alignment of IMU data, and it's already up and running. So we can look at geohazard risk over time as well. That's already up and going.
Okay, Luis Gonzalez is asking, do you need historical failure data to actually predict feature failures? And if so, what is the time span needed for that data collection?
Shall I answer that one?
Okay, so it really depends if we're trying to create and validate a new model or transfer an existing accepted industry methodology into a codified way that allows things to run very quickly. So, for example, probability of failure for a corrosion feature, there are several very good accepted methodologies in how to do this, and where we can come in, and what we have done already is go in and make it possible to assess those in a feasible time frame. It doesn't take a day, it takes 5 minutes or less. Where we have to go in and generate new methodologies, yes, those need validated. And really what you're trying to validate will decide how much data you need to be able to validate it with for historical data. And I suppose I guess the question was perhaps a little bit pitched towards ML and AI. And what we find actually is it's worth spending the extra time, the extra money on developing really novel mathematical models rather than just diving in with AI and ML every time. It has its place, it's very useful, but equally mathematics is very powerful on its own.
I mean, and I think also if you think about risk assessment methodology, you know, you're working out a risk based on the probability of failure times the consequence. The probability of failure is often based on statistical data, and sometimes the problem with that is you make an assumption about the relationship between that statistical data and the actual pipeline. So any kind of data, any failure data is kind of useful in that process. So you definitely do not have to have it, but the more you have, the better, I'd say.
Brilliant. Alejandro is asking, how does this work for facility integrity management? Do you have any case studies you can share?
I'll leave that with Nigel.
Yeah, we've really focused this on PenSpen broadly address midstream oil and gas assets, and we in terms of our digital transformation journey, we had to start somewhere, and we started with pipelines. So the whole principle and everything we've done here would equally be applicable to facilities. Certainly applying the same techniques to piping and pressure vessels and tanks. But that's kind of the future for us. I mean, it's that will be the version 1 point something or 2 point something. So yeah, I mean the technique definitely, and the data ingestion, the automated reporting, it all could be applied to facilities, but it's some way off on our roadmap, to be honest.
Okay, great.
We're initially pipeline focused.
I think that goes some way in answering Louis' question. He had asked, could Thea be customized to different types of transport systems? So slurry, water, tailings transport, those sort of things.
Definitely.
Mm-hmm. Yeah.
Definitely. The way it's built with that data modeling layer and the application, we can take pretty much anything that someone's developed or we can develop and incorporate into that, so we can do custom applications for any kind. And we've already done similar things for slurry pipelines. We have a background in risk assessment of slurry pipelines already. So
great. Raphael has asked, are you going to sell this in a module format? So can he just buy the parts that he wants?
Yeah, I mean the software as a service is the model, so it's a subscription, so it's a monthly fee. And there's kind of 3 dimensions to it. There's users, there's pipelines, and functionality. So we've been quite generous on the user side. So we're not restricting the number of users, providing they've got a company, a verifiable company email address. So really, it's functionality is the other dimension, and we bundled it. Or you can divide. You can then license individual, or you can subscribe to individual modules. So just for example, just the e-learning, or just the assessment, or just the risk assessment is perfectly possible. So
here's a good question for you. What does it cost?
Very good question. Yeah, my boss has told me I'm not allowed to answer that one.
Got it. Okay.
Good time have a chat further.
There are a lot of factors in deriving a rate, because obviously what does it cost is a bit like how long's a bit of string, because if you've got someone that's just interested in the e-learning compared with someone that's got 150 pipelines or even 500 pipelines, or even and wants everything right from risk assessment, so the cost is enormously varied.
Okay, great. We've got time for maybe one more question. If we haven't asked your question, then don't worry, we will forward it to the team. We've had a lot. So let's see where we should finish.
Liz, you broke up a little bit there. Maybe if you can just
Yeah.
ask the question again.
We
Yeah,
missed that.
sure. Yeah, we've had a few questions that are on the same theme, which is really talking about the move towards digitization. What will that mean for the integrity industry, and what are the new skill sets that are required now in this new industry?
Sure, I guess we can probably both answer that a little bit from different perspectives. So I come at it from directly from the assessment point of view. The industry has a problem with recruitment and retention in the industry. That's quite obvious. And what will be required, the team of guys I'm recruiting at the minute for the Thea team, they're not software coders. Nobody we've recruited yet is just a software coder. So what's required really are going to be the people who can understand mechanical engineering, chemical engineering, process engineering. That may or may not be from within oil and gas industry, but they need to be able to come in and bring real world engineering and translate that into efficient code. And from the integrity engineer point of view, the user's point of view, it will require a slightly better understanding of what's going on in the background. There's a very real risk, obviously, if everything's black box, that we lose competence. So there will be an obligation on companies to maintain suitable training as well, and that's part of what we're trying to address with the e-learning side. I'll hand over to Nigel with that.
Yes, I think it'll help, because it's a kind of different career prospect. Because I think some of the clunky methods, I think some people are interested in data science and getting insights from information. I think I think digital transformation will help make lives easier, make recruitment easier. But also, I think it will change the need for recruitment as well, because the type of people that we need will change quite a bit as well. The different skill requirements.
Great, thank you. I think we shall wrap this up then. Thank you, Nigel, for that great presentation, and Aidan for taking part in the Q&A. I'd also like to thank everyone who registered to attend today's event. Any questions that we didn't get around to answering, we will pass them on to the Penspen team. And if you have any further questions you'd like to ask, or you want to give any feedback on the webinar, if you could email Annie Ross at Penspen, she's a.ross@penspen.com. If you're interested in hearing more about Thea, you can request a demo via their website, and we will link this demonstration in a follow-up email to you. Finally, as always, everyone registered for today's event will receive a full recording via an email in due course. So thanks everyone, and goodbye.
Thank you, everybody. Goodbye.
Thank you.